Now, so we will start. Okay, so I will start with a couple of things. Okay, before we actually start on the analysis part. Okay, I want you to actually look at carbonyl compounds. Okay, carbonyl compounds. Okay, we have learned that when you have this compound, aldehyde and ketone, okay, we can actually do testing for them. Okay, I'm not going to actually write it down over here. You can refer to the video that I have actually uploaded in YouTube. So we can actually do certain testing, okay, to find out or to confirm the presence of carbonyl group, or sometimes we can actually do certain tests to find out whether the compound is aldehyde, okay, in comparison to ketone. So there are total of 4 tests. Okay, one of it is going to be 2,4-DNPH. Second one will be tolerance region. Third one will be Fehling solution, and then the fourth one is triiodomethane reaction. For 2,4-DNPH, okay, the reaction, okay, the positive reaction for that, you are going to get a deep orange precipitate. You are going to get that. And this test is used to identify carbonyl compound. So whether it's aldehyde or ketone, you are still going to get the positive result. Okay, so you need to take note of that. Okay, for second reaction, okay, which is going to be the Fehling solution. Okay, for Fehling solution, is going to be a solution that contains Cu2 plus, okay, alkaline condition, and you need to warm them. Okay, you need to provide heat. And then what's going to happen is going to be from blue solution, the clear blue solution. If you're testing aldehyde, the clear blue solution, when you heat, okay, you are going to actually get orange precipitate. Okay, orange precipitate or red precipitate. Now, for the third reaction, which is going to be tolerance region is going to be a solution containing alkaline silver nitrate. Okay, alkaline silver nitrate solution. So basically how it functions, the Ag plus silver ion will change into silver. Okay, so you will get some kind of metal formation, which is the silver formation. So we call it as a mirror test. So if you have a formations of some kind of mirror, okay, in the test tube that you have, okay, when you are testing with aldehyde, okay, if you get the mirror formation, okay, that's going to be a confirmation that the compound that you're testing is going to be aldehyde. Okay, that's going to be one of the important features over here. But do remember, okay, for tolerance region, you do not need to heat. Okay, you do not need to actually warm the mixture. You just actually mix and then you will get the result. The fourth reaction is going to be related to triiodomethane reaction. Now, the triiodomethane reaction is very specific. Okay, it can actually test for certain compounds that has C double bond O, but it must be attached with CH3. So one of the compound, okay, when it comes to aldehyde, you can only test for ethanol. Okay, you cannot test any other aldehyde. Other than that, if you have methyl ketone, any ketone that has methyl group over there, it will give you a positive result. And this test can actually be used to test for certain alcohol that has the CH3 and H attached to the carbon containing OH over there also. You can see all this, okay, in the YouTube video that I actually uploaded today. Now, the positive test for this, okay, is the formation of CHI3, which is triiodomethane. Triiodomethane, when you warm them, when you actually heat them, okay, the aldehyde, okay, or sorry, not the aldehyde, the compounds that has the specific structure that I mentioned just now, they will actually change it into a yellow precipitate or yellow crystals. Yellow crystals will be formed. So that's going to be a positive indication. So we have total of 4 reactions that you need to know for this testing for aldehyde and ketone. Now, after the test, okay, we are going to actually look at, okay, the reaction that is involving analytic. Okay, if you have analytic, okay, when we have, for example, when we have, for example, if you have organic compounds, okay, and then when you want to test them, okay, what we can do is we can actually do certain tests, okay, we call it analytical tests, okay, rather than just mixing them. Like for example, you want to test whether this is aldehyde, this is ketone. Just now we test using chemicals, okay, we use triode reaction, we use Fehling solution, we use toluene, we use 2,4-DNPH. But other than that, we can actually use some other chemical analytic method, okay, to actually test for certain compounds. So how we do that, okay, this one involving certain uh, application related to physics, okay,
Sir,
whereby, okay, yes.
sir, is the screen supposed to be blank?
No. You're supposed to actually, yeah, it's supposed to be blank. If you don't see me, then it's going to be blank. I haven't shared anything yet.
Okay.
Okay. So you want to see something. So I'll show you something then. Okay. Basically for analytics, okay, chemical analytics, okay, this one is actually got to do with some some application related to physics, okay. What are the application related to physics over here? Okay, there are certain things that are concepts related to physics that we will apply, okay, when we want to actually use that concept and relate it with chemistry. So one of the concept is going to be infrared spectroscopy. Okay, what is infrared spectroscopy? Okay, so basically infrared spectroscopy is going to be a method, okay, where we are going to actually have a sample. Okay, this sample can be any sample. It can be uh, any organic sample, okay, any organic sample. What we do, we irradiate, we do pass them, okay, with an electromagnetic wave. And this electromagnetic wave, they have the infrared region of the spectrum. So they will actually be passed with this wave. And this wave, okay, according to your physics, okay, you should know that, okay, if you have a sample, all organic compounds or all organic molecules, they absorb the infrared radiation. It means they can actually absorb that. Basically, they are going to absorb in form of energy. Okay, they will absorb in form of energy. Now, if I have this, for example, a compound, and then I put the electromagnetic wave over there, certain part of the electromagnetic wave will be absorbed by the compound, and certain part of the electromagnetic wave will actually be remain unabsorbed. So the one that is going to be not absorbed will be detected by a device. Okay, the device that we are going to use is called spectrophotometer. Now, this spectrophotometer, okay, will detect the intensity of the wavelength that passes the sample. So basically, okay, the energy that is absorbed over here by the sample, okay, they correspond to the changes of vibration of bonds. So do take note that organic compounds, they actually have bonds between them. And this bond, when they absorb energy, what happens is, one, they can actually stretch. They stretch, okay, they stretch. And then some of them, they will be, the bond will be bent, okay, they will bend. And some of it is going to be, the bond is going to be twist, okay, they will be twisted. So there are going to be certain kind of changes of vibration when it comes to the atoms, okay, the bonds of the atoms. So all of them, okay, according to physics, they have natural frequency. And if we can actually match the natural frequency using the electromagnetic wave that we use, okay, what we do get is, according to your physics, you should know resonance will be achieved. Resonance will make sure that you will have a maximum amplitude. Okay, these are the some of the terms in physics. So basically, it's similar to chemistry. This will cause a larger vibration. What kind of vibration? Stretching, bending, and twisting. It will be larger, more. Okay, the energy is going to be absorbed more. So it's called resonance frequency. So what we are going to do is, we are going to actually find out, okay, what is going to be the absorbance, okay, how much is going to be absorbed. So we actually found out and then try to match, okay, the details, the data is given for you. They found out that, okay, if you're using the device, okay, if you have the C sigma bond O, the absorption range is going to be like this, and so on. So they have certain terms that they use over here, which is going to be S and W. What is S? S is going to be strong. W is going to be weak. Okay, weak, strong. And then we also have this certain term called sharp and also broad. Okay, broad is going to be something that is going to be broad. This is broad. Sharp is going to be something like this. This is sharp. Okay, so if let's say we go to the, let's say later I'll show you, okay, some of the graph that you will get, but I'll just go through here. They are going to have certain characteristics of width over there, which is going to be broad or sharp. Just now I mentioned to you, broad and sharp. And then the intensity of the absorption, if you absorb more, okay, then you are going to get a strong absorption. If you absorb little bit, that's going to be a weak absorption. And there is one part over there, okay, you need to ignore the 800 to 1400 region. Okay, this one you do not need to worry, because do remember, organic compounds, they absorb the infrared radiation. So there are certain regions that you do not need to actually look at it. Okay, that is called fingerprinting region. So we no need, forget about the term. Okay, the point over here is from the region of 800 to 1400, you do not need to look. I'll give you some examples over here. All these examples are taken from your textbook. Okay, so this example over here, if you look at this red box over there, why I put the red box over there? Because I do not want you guys to look at the 800 to 1400 region. So this is going to be 800, somewhere starting from 400, so 1400. So we do not want to look at this part over here. I do not want to see. Whatever that I have over here, I'm not going to look. Okay, I'll show you with one example over here. So you see, this is one example of question over here. I do not want to look at from 400, okay, to 1400 to 800, somewhere here. So basically you can ignore the up to here also. So anything that comes over here, okay, the one that has a lot of absorption, okay, ignore. The same thing applies over here. From here, you take and then ignore. So what do we see? Basically, we can see this region, we can see this region, we can see this region. Same, we can see these regions, maybe this region also. Okay, so if I just go back to the original example over here. Now, this example, okay, is actually to show that this is going to be for ethanol, alcohol. And I have actually cut and actually give you some example over here from here, generally from this table, saying that if it is alcohol, so this is going to be OH. So they say that, okay, if you have going to have a free alcohol, this is going to be a free alcohol. So you have 3580 to 3650, 3580 and then 3650, probably somewhere 3580. So probably somewhere here, okay, from this region. So that's going to be the absorbance for alcohol. Okay, so they mentioned over there, you can actually identify that that is alcohol. Now I will teach you some tricks and tips. Okay, now if you look at the top over here, okay, this one, okay, is something that you need to memorize. Okay, if you have alcohol, okay, the absorption is going to be broad. Okay, and then the absorption is going to be from 3200 to 3550. You can memorize this. For carboxylic acid, okay, the absorption is going to be very broad. Later I'll show you. Okay, this is the example of carboxylic acid. You can see the difference. Okay, this one is broad. Okay, broad, and this one is going to be very broad. Okay, broad. You can see the difference over here. And then for ketone, this point over here. So basically, if this is going to be alcohol, so we just look at this part. But this is just a reference for you. But what we need to do is we need to actually look at the value that is given in your data booklet. So we are looking at this, okay? But if you want to answer the question properly, you want to identify the compound easily, I will suggest to memorize this. Okay, what to memorize? I will suggest you to memorize this range, 3,200 to 3,550. Okay, and this is going to be absorbance. Here 0 is going to be no absorbance at all. 100 is maximum absorbance. So it means if you have up to here, this is going to be close to 80 something, 90 something. So possibly this is a very strong absorption. Okay, so you can see that. Okay, like for example, this compound, if I want to actually tell that this is alcohol, what is the trick? Okay, the trick over here is something like this. I'll just erase over here. The trick is quite simple. If you see any compound around this range, 3,200 to 3,550, and they have this structure. Now, if you put over here, okay, if I rotate this, okay, if I rotate this, it will look like something like this. What do you get, Wesley?
Huh?
Wesley, what do
Yeah.
you see over there?
A smiley face.
Yeah, a smiley face or some kind of a ghost showing you the peace signal over there. Okay. Okay, peace. Okay. If you can see that, okay, if you can see that, that is going to be indication. Okay, that's an indication that this is alcohol, but this is not a total indication. This is just to help you. Okay, but I want you to memorize this part. Now, for carboxylic acid, it's going to be slightly different. Okay, they are going to be very broad. Okay, this is going to be an indication, very broad, and then the range is 2,500 to 3,300, 2,500 to 3,300, somewhere here, the absorption. And then, okay, there is another one because it's carboxylic acid, so they are going to be also having this absorption over here because C double bond OOH. And there is a strong and sharp at 1,640 and 1,750. What they mean over here is this part. So if you want to actually memorize this, probably something like this, very broad, and then something like this. So that's going to be an indication for carboxylic acid. So have a look, okay? But I cannot actually say that, okay, for this alcohol, it has a ghost with a smiley hand signal. No, okay, you need to mention that they have a broad, okay, absorption, okay, at 2,500 to 3,300. You cannot just randomly see from here and then give a value. No, I want you to memorize this part, okay? So it has that, and then you can actually mention how do I identify this is ethanoic acid. So that's going to be a very broad, okay, at what region, at this region. And then they have also a sharp peak over here, a strong and sharp peak at 1,640 to 1,750. You do not need to give an exact value over there, no need, okay? Or if you want also you can, but make sure it's within this range, okay? You need to memorize this. Now, the last one here, okay, this one, definitely not alcohol, definitely not carboxylic acid, because they do not have something like this, or they do not have something like this, and then like this, okay? So this one is very special. So this thing and this thing will help us to identify. So I took some part over here. This is going to be ester. So ester has a very sharp peak at 1,040 to 1,300. So this is going to be the part over there. And they also have, okay, another peak over here, which is going to be 1,700. So this part, okay. So the question is, how about this part, the 3,000? Now the 3,000, okay, will actually correspond to other things. Okay, if we look over here, 3,000 can be coming from any part from the CH bond. So take note that they also have CH bond. Okay, so it's not very specific. So you can actually just mention that the moment, okay, you have a very sharp peak over here, and then the moment you have a very sharp peak over there is already an indication that this is going to be ester. So how do we find out? Basically referring to this. I want you to memorize this part. Is that okay? So if we try to answer roughly, yeah, even according to what I told you, what do you think this will be? Helen, is it going to be alcohol, ester, carboxylic acid? Hurry up, we only have 6 more minutes. Hansen? Hansen?
Alcohol, yeah.
Yeah, this is already alcohol. You can see this structure, but you don't actually mention this structure. So you mention about, okay, there is going to be absorbance at very broad absorbance from this range to this range, okay? And then how about this one? This one is not carboxylic acid, so we are going to refer to this part and this part. So this one is going to be more like a butanol, okay, butanol. So how do I know it's going to be butanol? Probably you look over here, butanol, okay, ketone. Okay, ketone will be 1670 to 1740. So this one, okay, absorbance is there. And then how about the 3000? Probably the 3000 is only for CH. And then how about for this one? Okay, so near to 3500. So you can actually look over there, 3500. Is there something related to ketone? Let's see, 3500 related to ketone. There's nothing, probably something to do with this one only. Okay, so the indication over here that this one is going to be a ketone is only this part. So this one is this skill to identify these things, okay, they are related to this compound or that compound, you need to take note, okay, it is very important. Okay, so I hope you understand, okay, the topic today. Okay, I never say that the topic is easy, but the topic is very short topic. Okay, they don't want you to learn a lot of things, okay, but at the same time they want you to be able to identify the compounds. Okay, how do you identify the compounds? Okay, the trick is, okay, this one. Okay, this is going to be the trick. If you have this compound, that's going to be alcohol. If you have this and this, that's going to be carboxylic acid. Okay, if you have, for example, some other compounds, you need to actually refer to the data booklet, and then from 800 to 1400, that part you ignore, you don't want to see, okay, all that. So you need to actually understand this part. Okay, now this session will be actually uploaded in YouTube together with the previous session. It's the same thing actually. I want you to actually learn from this. Okay, you can just go through the video again. Okay, you refer to the textbook, go through it again. I will actually give you some notes, but that notes is also the same. It's not so required, okay, for your level. Okay, probably what is important over here is to find out, okay, about the how to answer the question. And I will actually give you some questions starting from tomorrow. Is that okay, everyone?